Vectors are different to scalars because vectors have a length and a direction. The direction of the vector is called the magnitude, and that can be described by component form of a vector. For example, vector v, underline shows us it's a vector, is 12, 5. This is the component form, or it could be called a column vector. 12, if we were to draw a sketch, 12 is the length in the x direction, not drawn to scale. So that means along to the right 12 boxes. And 5 is the length in the y direction. Positive is up, so it's 5 boxes up. So this is v, not drawn to scale. So we can find out the direction and the length using these numbers 12 and 5. If we wanted to work out the magnitude of the vector, we can use Pythagoras' theorem. So the length of the line v is actually the hypotenuse of this right-angled triangle. It's right-angled because the x and the y axes are always at right angles. We write the magnitude using these vertical brackets. Magnitude of v equals the square root of 12 squared plus 5 squared, because this is essentially Pythagoras' theorem. 12 squared is 144 and 5 squared is 25. So adding these up, we have the square root of 169, which is equal to 13. Magnitude of v is equal to 13 using Pythagoras' theorem. The second example, we can take the vector u, 1, 3. Find the magnitude of u. We write vertical brackets around the vector u. Remember to underline your vector to show it's a vector. We need to square the 1 and the 3 and square root those. Square the 1, square the 3, add them up and square root. So the square root of 1 plus 3 squared is 9, so that's the square root of 10. We can leave it like that. We don't need to write a decimal, but that's another option.